Because there are 3 basic orientations for how you can divide a lid from a base, and then there are 2 basic orientations for how you can apply the hinge, that gives us 6 fundamental constructions that we can kind of start with. By putting the hinge on different faces, you get very different moments of opening here. We concluded that hamburger style seam, short face hinge was the ideal, was the optimal to make the best card case in the world. But it caused a problem. It caused actually a whole series of problems. We spent 4 years solving the problems that were created by this decision. Anyways, the path that the lid travels intersects with a lot of the interior volume. I will just put a card in here. Oh no, I can't open it. The most obvious solution, you move that seam line up to the top. You're not gonna have any interference with your card. There's some drawbacks to this. The card is now fully seated inside. You have to essentially dump out your cards and like fish through and figure out what you're looking for and then put the rest back in. There's another solution here that you actually see fairly frequently, just make the case wider. And this does solve the problem. You can open your case, you can grab the card, but it has like all of this dead space. The idea that you would carry around a case that intentionally, knowingly has dead volume inside makes me feel like an idiot. I'll show you an example, maybe the best example of the perfect hinged case, the perfect hinged container. Baby Bell cheese. There's no interference as you pivot the lid up on the hinge, and then you have full access to your contents. It's perfect. Baby Bell has it a lot easier because they are working with perfect circles here. The contents are already arced and you're not going to have that interference built in. But there is a way to achieve an almost similar amount of efficiency for a rectangular object. And it's pretty simple, but it's also pretty satisfying. And so I will give you a second to think about that. They're fucking around. I don't fuck cigarettes. I was just kind of giving you a little hint here. If you take a closer look at this pack of cigarettes, you'll notice something interesting about how this hinge is divided, which comes down at an angle. So if you take this original arrangement, you keep the lip exactly where it's at, but then you bring the hinge all the way up to the top, you kind of get the best of both worlds. Because if you follow the path, you'll see that it shoots far outside of the interior volume, but you get the added benefit because of this lower front lip where you can easily access, add, and remove your cards. With like a little bit of additional refinement, you effectively arrive at the construction of our original Summit card case, which is what I have in my hand right here. Open corner that you can easily kind of grab your card, takes up most of the interior volume. This was made out of pewter by an amazing pewter craftsman in the UK. We only had about 110 of them, sold them out in like a day and a half. And so there was like a couple days of like celebrating, like, holy shit, we have a new hot product. A week and a half later, started to get some emails that locking mechanism that would keep the lid closed was starting to fail. The pewter was too soft. We went back to the drawing board and basically decided that we were trying to recreate this whole construction, the same design effectively, but we were going to make it in stainless steel. There was still a small percentage of units that were having the same issue. Over time, studying this, realized that there was kind of a fundamental issue with this construction that we had designed where the lock was at the front lip and the hinge was at the back end of the design. If there's any deformation, it's very easy for the lock to stop engaging. And even if it does stay closed, it's just kind of free flowing floppy. Depending on your orientation, it has the ability to fall on your fingers. We were a little bit stumped. The seed of the solution came from a 120-year-old sample that I bought on auction, and I have it somewhere. This guy. This beautiful little weird case is a Vesta case, basically intended for keeping your matches dry. Discovered that it has this very rudimentary but very effective locking mechanism that's built around the hinge itself. The locking mechanism that we have is a type of slip joint. Solves both of the problems that we were having with the card case. I think I can explain. If you add that locking force over to the hinge side of the assembly, add essentially a chunk of material to the lid portion of the hinge, you have introduced a slip joint. If you have some wear and tear, it's not going to really impact how secure the lock is in the closure. But it also solves the second problem. You no longer have this floppy lid. That same slip joint is now holding the lid open. The lid's not going to snap closed on your fingers. We implemented that first basically by directly copying what's happening in the Vesta case. Added the same interference sheet metal tongues into the base and the lid, and it worked. It did the things that we wanted it to do. But there were several drawbacks. I mean, maybe it's the story of every design project, but it's like, this is the story of this project in particular. This 2 steps forward, 1 step back. It still rattles. This thing is like actually not as precise as we wanted it to be. And it's like pretty ugly the way that they like welded these tabs in. And it takes up a lot of space. There's like a pretty sizable spine of the card case that's basically no longer functional. So there was things, I mean, we were onto something. We tried hard. There was like 3 or 4 rounds of sampling, just couldn't get it consistent enough. Kind of came to the difficult conclusion that to solve the 2 remaining issues would require us kind of going back to the drawing board and think about a totally new manufacturing process. Opened up these possibilities and allowed us to achieve a much more satisfying and elegant slip joint. And I'm excited to like get into some of the details of that refined engineering. But before that, I'm really excited to just like explain this manufacturing process a little bit more. It's like one that I've wanted to use for a long time. And Kevin and I went and visited some of our factories in China to like see and document some of the process firsthand.
That was maybe the most shocking part, was seeing the dough mixer and it starting as dough.
Yeah. Or powder.
It did start as powder, the atomized steel that gets mixed with the pellets and then dough, and then spat out as little tiny rabbit poops.
Yep. Little rabbit poops. It seemed like snow caps without the caps on them.
I don't know what snow caps are.
It seemed like Hershey Kisses.
Okay, yeah. And then it goes basically through an injection molding machine.
Dough pellets are loaded in. They get fed into this plunger of sorts, and this huge pneumatic arm comes and forces the molten material into our mold, which is behind this piece of glass here. Once it sets, the mold opens up. The ejector pins push the part out of the mold, and the suction arm carefully removes it and delicately drops it right onto the conveyor belt to finish cooling.
I think the surprising part was like the size of
Yeah,
the pieces.
the parts were big.
After the injection molding phase, it's metal plus plastic. There's inherently just more there than we wanted, which is why the form is so much larger.
The degreasing is the first step, which removes a lot of the plastics and the oils. It becomes really brittle.
Yeah.
Oh, that was way more brittle than I thought.
And then it goes into the sintering oven for like a day at 2,000 degrees, and all the powder fuses together and the remaining plastic burns off, but then it finally shrinks that final 10 or 20% to become the size that we expect it to be. It's at this point in the manufacturing process that we can show you the different engineering details that make this a much better slip joint. And so I think we can go back to the design room.
Yeah.
Need hair and makeup in here.
All right. Woo. Our team is growing, so this room used to be all for fulfillment. So this whole wall was our product, finished product in the packaging, and it's turning into our new shop. Right now we use it for reminiscing. It's a big open floor to lay down and think. It's a different kind of fulfillment, mental fulfillment. Back to the design room. In the original Summit card case, the lid was attached to the body with a tertiary hinge that got tack welded on. In our current version now, the hinge has been integrated into the body and the lid. It is all one. And that integration has led to a more robust construction.
But wait, there's more. What the MIM process also allows, in the previous testing we were doing with the sheet metal construction, we had welded on a leaf spring to the spine of the base and then welded on a separate kind of interference bar to the lid. So what we did with the MIM version, first is that we designed in this slot. It captures the leaf spring perfectly placed where it needs to be. And instead of needing this kind of interference bar welded to the lid, we kind of figured out that you could actually just add this chunk of material to the hinge portion of the lid that creates the interference on its own. Engineering details I think are pretty exciting, but then once you fully assemble, laser weld, finish up the exterior, the most satisfying aspect to me is how the action feels and the pressure that it provides and the feedback that it provides. It just feels like right.
Especially after spending so much time on something like this, to land here with such a substantial product that is so satisfying, it's the ultimate happiness, I think, as a designer. This wouldn't be here if we did not design and release its predecessors.
If you have a previous version and the mechanism isn't latching correctly or you're not otherwise totally satisfied, shoot us an email and we are going to send you a new one because that's the right thing to do. You're a part of that learning and that process with us. Thanks, guys.